Hello everyone, welcome to our channel EduWorld. In this channel we are going to upload videos on scientific topics which will be very much helpful for the students who are from the scientific background. So please like, share our videos, comment in our videos. If you have any doubt or any question you can ask, feel free to ask questions, and obviously subscribe our channel. So in this video we are going to talk about resultant of vectors. So to talk about resultant of vectors, first we will have to understand physically what is the meaning of resultant. What is resultant? Resultant is simply the combined effect of two vectors when applied together. Okay, when applied together or together in action. So if we give an example, this will be more clear to you. So say there is an object on which you are pulling that object with a force say 5 Newton. Now your friend has arrived and he is trying to pull the object with the same amount of force, which is 5 Newton, but in the opposite direction. So what will be the net result on that object, or what will be the net effect on this object as two forces have been applied on this object? So what will happen? As your friend is opposing you totally, so the object will not move. But if your friend decides not to pull that object in this direction but in this direction, then what will happen? Now what will happen? This object will start to move in this direction. Okay, and if your friend keep changing this direction, so the effect on this object will also be different. Okay, so when we add two scalars, I mean say if we go with an example, say you are carrying a bag which weighs say 5 kg. Now someone puts 2 kg in your bag, so now what will be the total mass of your bag? That will be simply 5 plus 2, that is 7 kg. Okay, but in case of vectors, to get the combined effect of two vectors, we will have to think about what will be the resultant of two vectors. So to get the resultant of two vectors, we use two theories. Number one is triangular theory, and number two is parallelogram theory. Parallelogram theory. So what is a triangular theory? Triangular theory is, say we have two vectors, like in this figure, one vector is x and one vector is y. So say now we want to calculate, or we want to evaluate the resultant of these two vectors. What we will do by triangular method, what we will do, we have drawn this vector, and from the end point of this vector we will draw the other vector y. Okay, now if we complete the triangle by joining these 2 points, then the other side of this triangle will simply denote the resultant of these two vectors. So this is the triangular theory. Okay, so these theories are graphical theories. Next, when we will study about the parallelogram theory, we will get to know that what will be the magnitude of the resultant vector and what will be the direction of the resultant vector. So parallelogram theory, here we can see that there are two vectors, one is small a and the another one is small b. Small a is denoted by AB and small b is denoted by AC. Okay, so we want to get the resultant of these two vectors. So what is parallelogram theory? Parallelogram theory is saying that if we denote two adjacent sides of a parallelogram by two vectors, say in this case AB and AC, then the diagonal passing through the intersecting point of those two vectors, that means the intersecting point of these two vectors is AB and AC, the intersecting point is A. So the diagonal passing through A, that is AD, will denote the resultant of these two vectors. So how we will get that graphically? So at first we are drawing the vector A and drawing the vector B. Now what we will do, we will draw a parallel line. Say this is AB and this is AC. We will draw a parallel line passing through C parallel to AB. So that will be like this. And we will draw parallel line passing through B parallel to AC. So that will be this. So this will give us the parallelogram. Now the diagonal passing through the intersecting point, that means through the point A, the diagonal will be this. So this will denote simply the resultant of these two vectors. Okay. So now how we will get the magnitude of that resultant and direction of that resultant. So to get that, what we will have to do, we will have to draw perpendicular from point D to the extended line of AB. So that is DE. DE is perpendicular on AB, okay, or AE. AE is the extended version of AB. So now from the triangle ADE, please try to observe very carefully. The triangle ADE is a right angle triangle, okay, because the angle DEA is 90 degree. So the hypotenuse is AD square, so AD square will be AE square, which is AB plus BE square plus DE square plus DE square. Now we know that AB is what? AB is A. Now we will have to get what is BE and what will be DE. Okay. So what are given? We have been given the two vector A, B and the angle between them theta. These are given, and we will have to get the resultant R. What is the resultant R? And the direction. To denote the direction of the resultant, we are considering an angle alpha, that the resultant is making this angle with a vector say A. Okay, so alpha. So we will have to evaluate what will be R and what will be alpha. Okay. So now AD square is what? AD square is, we got AB plus BE whole square plus DE square. Okay. So now what is BE? To get BE, we will have to consider the triangle BED. In the triangle BED, this is also a right angle triangle, and from the triangle this BED, if we consider cos theta, what will be cos theta? So this angle is theta and AC is parallel to BD, so this angle will be also theta, and cos theta will be what? Cos theta will be based by hypotenuse, so that is BE by BD. So what will be BE? BE will be BD cos theta, and what is BD? BD is AC, and that is, and AC is B, so this will be B cos theta. So BE is B cos theta. Similarly, we can get DE will be B sin theta. Okay, so BE is B cos theta and DE is B sin theta. So we put the value of BE and BD, so we get this. Now this is A plus B whole square, A plus B whole square. So if you get A square plus 2 into A into B cos theta and plus B square cos square theta. So B square cos square theta from this and B square sin square theta from this. So B square gets common. Within it becomes B square into cos square plus sin square theta, and this is 1. So this will be simply B square. So R square is equal to A square plus 2AB cos theta plus B square. So R will be what? Root over of this whole thing. Okay. Thus we can get the magnitude of the resultant. Now what will be the angle alpha? Angle alpha, we will have to evaluate the angle alpha from the same triangle ADE. So we can see that tan alpha will be what? Tan alpha will be perpendicular by the base, so that will be DE by AE. Now what is DE? DE is B sin theta, and what is AE? AE is AB plus BE, so that is A plus BE means B cos theta. So tan alpha is simply this much. So alpha will be what? Alpha will be tan inverse this quantity. So in this way we will get the resultant, the magnitude of the resultant and direction of the resultant. So these are some examples. So you can solve these examples. They are very simple examples, and after some solving, if you face any problem, you can comment in our video and we will help you to solve these problems. So thank you very much guys, and more we will talk about resultant of more than two vectors. Okay, so previously we talked about resultant of two vectors, but if we have resultant of more than two vectors, then what we will do, say in this case this is the point and forces F1, F2, F3 and F4 are applied on this point. So what will be the resultant? At first what we will do, we will try to consider the triangle theory. So we will draw F2 from the endpoint of F1. So this will look like this. So in the figure you can see that F2 is this. So if we complete the triangle, this will be our resultant of F1 and F2. Now we come to F3. So F3 we will try to draw F3 from the endpoint of the resultant of these two. So say that resultant is R1. So from this point we are drawing the F3. So resultant will be this. Say this is R2. Now R2 and is F4. So we will have to draw the F4 from the endpoint of R2. So this is F4. And if we complete the triangle, this will be the resultant of all these forces R. This is very simple. Okay. So thank you very much. In next lecture we will talk about how to resolve a vector into components and how we will get the resultant of many forces when applied on an object. Don't forget to subscribe our channel and please like, share and comment in our videos. Thank you very much.